going to get started today. So we get to start chapter 6, which is our chapter on learning. And this is my favorite chapter to talk about for this class. Probably because this is the part that I have the most experience with. I will, if we have enough time towards the end of this chapter, spend just a little bit of time talking about actually conducting research in terms of learning. So I've already mentioned I've done work with operant conditioning. So that is the second last, I guess, type of learning we'll talk about in this chapter. So if we have some time at the end, I'll do a little bit of a sort of side lecture on how that looks in reality and how you might actually conduct research like that and some of the aspects involved there. But when we're getting started here, we should probably start with our base definition of learning. And this is one of those concepts that has a pretty variable definition depending on who you ask. But we're going to say that learning is an enduring or durable change in behavior or mental processes that occurs due to experience. So that's quite a lot going on. But we're going to break it down into sort of 3 essential points. The first is from that enduring or durable change. We're saying that the changes caused by this learning is going to be relatively permanent. So it's something that's going to persist for a period of time. We can have sort of short changes in behavior, but then if we immediately go back to normal, that isn't learning, that was just a temporary shift. With learning, it's also going to be causing a change in behavior. Now this is sort of more of a technical thing. When we're looking at learning, the idea is to get at maybe some of the mental processes that are changing, or maybe the knowledge that we've acquired. But in practicality, you can't really measure knowledge. You can't sort of directly learn what our mental processes are. We've talked about those issues with trying to study things that aren't necessarily tangible. And so the best thing that we can do is look at changes in behavior. So if I wanted to study acquisition of knowledge as an instructor, that's where quizzes and tests and different activities where you would have to use that knowledge, that's where those come in. So it's a way of measuring a change in performance or behavior, and if you do it right, you would set things up so that you could only do a particular behavior, or your behavior would change in a particular way only if you had acquired certain kinds of knowledge. And so when I talk about our operant conditioning with chickadees, I talk about sort of the different expectations that we would have if chickadees were forming concepts or if they were just memorizing. So different behavioral responses tell us something about those internal mental processes. So we focus in on behavior as a stand-in for some of those other things that we might be interested in too. And then this change is caused by experience. So from interacting with our environment, we sort of experience things and learn about those things that we encounter. So it's all about things that we are encountering and learning about by experience. And this could be, I suppose, like if somebody tells you about something, then they're telling you that, you're experiencing it through someone else. But usually when we look at learning, we're going to be looking at you're exposed directly to something and we see this resultant change in behavior. Okay, so this is our roadmap for the chapter. These are the 4 basic types of learning that we're going to talk about. I actually find that not all textbooks include the first type of learning, and that's event-alone learning. So I'm actually going to start with habituation and sensitization. Those are our event-alone learning categories, just because I find that they provide a really nice starting point. It helps us get exposed to some of the terminology, and then it'll move us on into our next type of learning, which is event-event learning, which would be our classical or Pavlovian conditioning. And then we'll move on to our behavior event learning, which is instrumental or operant conditioning. And then we'll finish off with social learning. Now, right now, these terms aren't necessarily going to mean anything to you. We'll sort of start explaining that event alone, event, and so on, talking about exactly how they apply in each situation. So we'll start piecing those together a little bit today. But this roadmap is more of it'll make sense to us once we've gone through the topics. So if you haven't gotten it yet, don't worry about it. This should give you a hint about something that we've already kind of encountered. So when we started with our definition of learning, we found that there's lots of different ways that we can talk about that. Everybody has different definitions. We also find that it's the same for a lot of our terminology. So classical conditioning is also called Pavlovian conditioning. Instrumental conditioning is also called operant conditioning. And this is just sort of mess due to the field. I think technically classical and Pavlovian conditioning are things that different groups of people preferred different names. And so half of the literature used one and half used the other, and then they were kind of forced together, so now you use both. Whereas instrumental and operant conditioning, I think that one was actually because two separate groups were studying the same thing and called it something different, and then realized they were studying the same thing, so they had to unite. But that stuff isn't important. I just find it a little bit interesting. So there's going to be a lot of different terms, and I'll kind of let you know what my preferences are and what you would likely see. But as you've kind of figured out, I like to use sort of multiple things, and I'll typically use brackets in my questions to make stuff clear for you. But before we get into any kind of learning, I actually want to detour and talk about unlearned behaviors. So if we're focusing for the rest of the chapter on things that we've learned about, and specifically things we learned through experience, that might make you start thinking about what we had talked about early on with our nature versus nurture of what leads to a particular behavior, or looking at the genes and the environment influencing some kind of observed trait or phenotype. It's all the same basic idea. So a behavior can have an environmental component, the stuff that we learn from experience, how we're raised, that nurturing aspect, but it can also have some kind of baseline, innate, pre-existing genetic component. That's our nature component. And so we have some behaviors that occur on their own without any learning. So for us, if we talk about something being innate, it's something that's naturally occurring, and we're going to frame it usually as something that has a genetic base. So it has only the genetic side of things. There's no need for learning. There's no need for that environmental component. And so this is the first of our wonky terminology. So we're going to use the idea of a reflex to talk about something that is happening automatically, and specifically something that is innate, something that we haven't had to learn about, that happens automatically. Technically, you can use a reflex to refer to anything, whether it's learned or innate, that happens automatically. And we'll actually see in classical conditioning that you can have learned automatic responses to things. And so instead of talking about learned reflexes, we just call it conditioned responses. So if ever I'm talking about a reflex, if I don't specify otherwise, we're talking about innate things that happen just due to our biology, things that occur without learning. And then if we're talking about sort of learned reflexive behaviors, we're talking about conditioned behaviors. Just as sort of help clearing up that, because you will see the terms used differently depending on sources. Okay, so now we can actually start with the learning side of things. So we're starting with our event-alone learning. And our two big terms here are habituation and sensitization. And so when we call it event-alone learning, we're saying that there is a single event, and we're going to learn about that event on its own. So for us, an event would be exposure to a single stimulus. So maybe you hear a sound or see something or whatever, and you're going to learn something about that particular stimulus. So that's why it's called event alone, and it's the simplest form of learning. It's so simple, in fact, that most texts skip it, but like I said, I like it. So if we have our definition for habituation, this is the process where we respond less strongly over time to a repeated stimulus. So if we encounter the same thing over and over again, we won't respond to it as extremely. So the example that I've been using to sort of help illustrate this section is maybe you have a sibling and your sibling has figured out that it's hilarious to jump out from behind a door to startle you. So they jump out from behind a bathroom door and it startles you. So that single stimulus, that single event of them appearing suddenly causes a behavioral response where you are startled. So a startle response. Okay, so over time, if we're habituating to this, maybe the next time you go into the bathroom, you know that they're waiting there to scare you again. So you don't jump as badly. And over time, eventually, if they jump out from behind the door every time you walk past the bathroom, then you're not going to respond anymore. Eventually, you will have habituated to that occurrence, and your behavior would have changed from sort of a dramatic startle response the first time to no reaction at the end of it. So we've seen that change in behavior because you've learned something about that event, that startling thing that no longer startles you. And the concept of habituation might sound familiar, and that's because we talked about habituation back in our sensation and perception chapter. And so there are sort of distinctions here. So when we're talking about learning and habituation, habituation here is a simple form of learning where we focus in on a change in our behavior. So having a large response changes down to having less and less of a response over time. With sensory habituation, that was like being nose blind, where you're surrounded by a smell for so long that you don't notice it anymore. So the chemicals, the odors that are in the air are still there. They're still registering on your sensory receptors, but you're no longer paying attention to them because they're constant. So you've filtered out irrelevant information because it isn't of any use to you. So with sensory habituation, the information is still there, you're just not attending to it at the time. So that's more of an internal process. With habituation as it pertains to learning, we're focusing in on that changing in behavior. So as you respond less to that event, that's the habituation that we care about. So it would be more of one of them is internal and one of them is an external behavior-based thing. So same term, but used in different ways. And typically once we've talked in the learning chapter about habituation, I will specifically talk about sensory habituation when we're referring to the sensory kind, and just habituation when it's the learning kind. But otherwise the context should cue you into that. Okay, so the process of habituation, the actual mechanism of it, was originally studied in Aplysia californicus, which is a sea slug. So these guys are kind of weird looking, and they're actually quite a lot larger than you would actually want them to be. So on average, they're about 12 centimeters long, but at full size, some of the bigger ones can be almost a foot, which is awful. And I didn't want to know that when I figured it out, but now that I know it, you guys have to too. But these guys are interesting specifically because they have a really nice reflexive behavior that can be harnessed to show habituation. So we can actually make use of a reflex and show learning in a reduction of that reflex over time, which is really cool. So how this works is, you can see in the diagram there, along their back they have a little slit labeled as a gill. And so that's basically a part of their skin that's going to open up and allow their gills out. So they're aquatic creatures, and when they're in a calm, relaxing environment, when the water's nice and still, they're going to open that up and allow their gills to sort of float freely. That gives them more exposure to the water and gives them better sort of air uptake. The biology of it isn't super important, but what we care about is they now have their sort of sensitive gills exposed to the environment. So Eric Kendall, the researcher who worked with these guys, figured out that if you poke them, they produce an innate reflexive gill withdrawal response. So when you poke them, they pull their gill in and they snap shut. And so you can let them relax a little bit. They're going to sort of calm down and they're going to open back up again. They're going to put their gill back out. And then you can poke them again and they're going to pull in. But he learned that if you do this consistently, they respond less and less each time that you do it. So eventually, maybe they're going to pull back in a little bit more slowly. So you can time how long it takes for them to go from fully extended to pulled all the way in. And then it's like a slower process over time. Or maybe you start seeing that maybe they don't close all the way up. Or maybe they don't even pull their gills all the way in. And eventually you get to the point where you can poke their exposed gills and they don't even move anymore. They've completely habituated to that mechanical stimulation of poking them. And so this was the first really well described process of habituating to that kind of exposure. Okay, so if we're going to talk habituation, we should also talk about the other side of the coin, and this is the concept of sensitization. And so if habituation is a decrease in responding to a repeated stimulus, sensitization is then going to be an increase in your responding to a repeated stimulus. So these are, like I said, two sides of the same coin. So if we go back to that exact same example of your sibling jumping out from behind the bathroom door to scare you, in the first example we said that, well, they've done it once, you're kind of used to it now, it's no longer as startling. That's the habituation side of things. If you are like me, the first time it happens, it's going to get you nervous. And then every time you walk by the door, you're braced for that next jumping out. And so when they do it again, you're going to startle, but you're going to startle even worse because you were sort of sensitized to it. You were braced for it. And as it happens more often, you're going to have a more and more intense reaction simply because of that internal emotional state. So that level of internal arousal, that kind of activation of your central nervous system, might lead you to have a more strong reaction over time. So that could be sensitization. It doesn't have to be driven by internal stuff. There are also environmental stimuli that can make something sort of more startling or more apparent. So you might have a stronger response because of other things. But usually we talk about it in terms of an internal state affecting it. But the cool part here is the exact same stimulus, the exact same event, sibling jumping out from behind a door, can produce either sensitization or habituation, just depending on different factors. So the same stimulus could lead to either, just depending on what else is going on in that system. And so if we wanted to talk just a little bit about what biases us towards one or the other, so with habituation, that tends to occur in very highly specific situations. So if your sibling always jumps out from behind the bathroom door and the bathroom door only, then you know to expect it there and it's not that big of a deal. So you're going to be more likely to habituate to it. But if they jump at you from behind the bathroom door and from behind the kitchen counter and from underneath the stairs and all of these different places, when you're not specific, when there's sort of that shifting aspect, you might be more likely to have that sensitization. So that isn't a always going to occur thing. That's just a general leaning of that. But we can have either or depending on our situation. All right, so nice and simple. That was our first type of learning. So if that was event alone, where we just have a single stimulus that we're exposed to, we might infer that event learning might be looking at an association between two different stimuli, which is exactly what classical or Pavlovian conditioning is. So we'll start with a little bit of history and kind of explain the discrepancy in names. So classical conditioning is often called Pavlovian conditioning, just because it was originally pioneered by Ivan Pavlov. So you've probably heard of Pavlov or a Pavlovian response. Maybe your mouth waters when you smell something delicious because it makes you think of food. That would be a classically conditioned response. So for a little bit of background, Pavlov was a very famous Russian researcher in the early 1900s, but his research was actually not set up initially to look at learning. He was set up to study digestion, so he ended up learning about learning accidentally. So in his lab, he had it set up so that he had different animals, mostly dogs, and they had cannulas, which is basically like a long tube that allowed them to collect saliva. And it would allow them to collect the enzymes in the dog's saliva. And so he wanted to study digestion and how that process worked. He also wanted to sort of bottle and refine those enzymes in order to sell them, because it was quite a lucrative business to help support the lab. But the way that this was set up was that the dogs would be in their kennels, they'd have these cannulas hooked up, and then he'd have graduate students who would go in the mornings and sort of get everything set up and run things. And so when the grad students would come in, they would open the door. The door happened to have a bell over it. So they would open the door, ring the bell, and then start their chores for the day. And because they were specifically collecting and measuring saliva, dogs would salivate when given food. That is a natural response to being given food. Even us, whenever we start eating, our mouths will start to salivate because that helps us eat. Natural process. But the students started noticing that the dogs were producing saliva even before they got access to food. So what was happening is, as soon as they heard that bell ringing when they came in the mornings, the dogs knew that they would be getting food soon, and they started salivating early. And so this gave Pavlov the idea that they had learned or associated the sound of the bell with getting food, and we were seeing a change in their responding, so they were producing saliva, not only to food, but now to this previously neutral stimulus, which was that bell. And so that process of acquiring these associations is what we're going to focus on for our classical conditioning section here. And so for our definition, so classical conditioning is a form of learning where a neutral stimulus comes to signal the occurrence of a second stimulus. So we're saying that that neutral stimulus, that sound of a bell, on its own, it doesn't necessarily mean anything, but it will come to be associated with, or it will tell the dogs that a second stimulus is coming. So the bell came to tell the dogs that they would be getting food soon. And we can see their behavioral response. They would have salivated previously just to the food, but now because the bell tells them about the food, they salivate to the bell as well. So that would be classical conditioning. And so I'm sure you can tell already there's going to be quite a bit of terminology involved in this process. So I made a little bit of a breakdown here. Classical conditioning exclusive terms will be on the next couple of slides. These are just some general learning terms that I find don't necessarily get defined right off the bat. But I've already kind of used some of these. So if I talk about eliciting a particular response, I'm just saying that it brings about or causes a particular response to happen. Scientists in general try and avoid using the term causes if we don't have any kind of evidence showing a causal relationship. So elicit is a less direct way of saying that. So when we say that that bell sound would elicit a salivatory response, we'd say that the dogs would start salivating when they heard the bell. So we've already defined a stimulus back when we were looking at our sensation and perception chapter, and it's basically any event in the environment that we can sort of perceive. But we're going to have an extra couple of caveats here for a stimulus, because if it's a stimulus that's relevant to learning, it also has to tick some other boxes. So it's something that occurs in the environment that we can detect, so something detectable or perceivable, something that we can measure, and also something that can eventually evoke a response or a particular behavior. So we're specifying in this case that our stimuli need to be things that can cause behavior to happen. So it's something that we can learn about. Just some extra things that we need here. We can talk about associations, and that's just our way of saying that there's a relationship between two stimuli. So when I said that the dogs had learned to associate the sound of the bell with the delivery of food, that's an association. And then acquisition is the process of actually acquiring or learning a particular association. So while the dogs were learning that the bell came to signal food, that's their acquisition period. After they've acquired that particular association, then we would just say that it's been conditioned. But acquisition is talking about the learning process. Okay, so those terms will apply to a lot of different situations, and we're going to see them pop up quite a lot in this chapter, but at least we have them all in one place with a proper definition now. So for our classical conditioning specific terms, these are going to be something that we spend a ton of time talking about because this is the core of this part of the chapter. And because it's kind of a weird and new thing to learn that you might not have been exposed to before, that you probably have not been exposed to before, we're going to take some time going over these. And I like to explain sort of why the names are what they are, because for once they're logical, which is very useful in this chapter. But we're going to start on this first slide with our unconditioned events or things. And so if we were talking about conditioning, we're talking about a process of learning. So if something is unconditioned, it means that it isn't learned. So if it's not learned, it's innate. So that's a quick way to think about what we're looking at here. And then a stimulus is the individual event that's triggering something, and the response is the behavior that occurs because of that particular stimulus, just as our baseline orientation. So if we want to put it together, we can talk about an unconditioned stimulus, sometimes shortened to US, and this is a biologically significant stimulus that already has a naturally occurring response associated with it. So this is something that has a naturally occurring or innate response that will happen whenever we're exposed to it. So in our Pavlov example, that the food would be an unconditioned stimulus, because dogs will naturally salivate in response to being given food. I will make a note here. This is one of those weird terminology things. I typically shorten unconditioned stimulus to US. Most textbooks will also shorten it to US because there's two words and it's the first letter of each word. But there are texts that use UCS because it's an unconditioned stimulus. But I find that kind of a weird way to set it up. So I use US. If you see UCS, same meaning, just preference. Same thing with our unconditioned response. It's called a UR, but you might see it as a UCR. Both mean the exact same thing. I try and say the words in full because the letters alone, it's not necessarily as useful and it's not going to stick in your brains quite as well. But just a little bit of a heads up there. So, okay, if our unconditioned stimulus is the thing that is naturally going to produce a particular response, our unconditioned response is that response that's naturally associated with our unconditioned stimulus. So this is the behavior that happens automatically or naturally when we're exposed to that unconditioned stimulus. Again, in our Pavlov example, our unconditioned response would be salivation. So an unconditioned stimulus is exposure to food, and the unconditioned response that's driven by or elicited by that stimulus is going to be that salivation, our unconditioned response. And so in both of these, they're unconditioned, which means we haven't had to learn anything about them. It occurs naturally. So that's our starting point. We also have something else that we don't know anything about at the beginning, and this is our neutral stimulus. So this is a stimulus that is neutral. It doesn't elicit any kind of response naturally. So with our Pavlovian example again, that bell over the door. A bell on its own, before you learn anything, doesn't mean anything to a dog. You have a dog that has no experience and ring a bell near them, it doesn't mean anything to them. They're not going to do anything. There's no naturally elicited response. Our examples for neutral stimulus here, a tone, a chime, a bell, they're all sounds, but it doesn't have to always be sounds. You can do classical conditioning with smells, you can do it with visual things, all sorts of different things. It's just a lot easier to conceptualize with sounds because it's something that we tend to attend to very well. So our neutral stimulus, this thing at the beginning, has no naturally occurring responses, but it will eventually change. So the stimulus itself is still going to be that bell sound, but we're going to call it something different as we start learning and making associations with that stimulus. So our neutral stimulus will eventually be called a conditioned stimulus, or a CS. And so our previously neutral stimulus will eventually come to elicit a conditioned response. So that bell is going to eventually cause the dogs to salivate. And so the conditioned stimulus would then cause a conditioned response. And so the conditioned response is a learned response that occurs because of an environmental stimulus, specifically our conditioned stimulus. Now I want to take a moment here and point out something that people tend to have a lot of trouble with. When we're looking at our conditioned response and our unconditioned response, both of those are the same behavior. So our unconditioned response was salivation. So we said that the dogs were salivating because they had been given access to food, their unconditioned stimulus. So in that situation, because it's caused by an unconditioned stimulus, it's an unconditioned response. But after we've done the learning process, we're going to call it a conditioned response. And that's because the dogs have learned to associate the sound of the bell with food. So now when they hear the sound of the bell alone, it will make them think of food because of that association, and they will salivate even if there is no food. So we call it a conditioned response because it's specifically been elicited by our conditioned stimulus. So the difference between the conditioned and the unconditioned response is just what caused it. What is the thing that's driving the production of that behavior? So if it's produced because we're being exposed to our unconditioned stimulus, because the food was there, then it's an unconditioned response. And if it's caused by our conditioned stimulus, the thing that we've learned about, or the bell, then it's going to be a conditioned response. But in both cases, it's still going to be the behavior of salivation. We just care about why they're salivating. What's the cause of it? And again, if this hasn't quite sunk in yet, not to worry. We have a couple more examples, and we're going to walk through it a couple of different ways. So hopefully it should continue to make more sense. So let's start with an example, sort of breaking it down. And we're going to stick with the sound of a bell and the presentation of food, just in a different orientation here. Sometimes the visuals help. So at the beginning of our classical conditioning procedure, we have our bell, which will become a conditioned stimulus. At the start, we would still call it a neutral stimulus. So it doesn't mean anything yet, but it will be a conditioned stimulus. Then we have our food. That's the unconditioned stimulus. The dog doesn't have to learn anything about it. And our unconditioned response, the thing that occurs naturally when they get food, that's going to be the salivation. So we do one trial, one cycle. So we'll ring the bell, we'll give the dog food, and they'll salivate. Well, if you only do it once, what's going to happen when you ring the bell? Probably nothing. You haven't given them enough information for them to acquire that association. So if you ring the bell and the dog doesn't do anything at all, then we know that the bell is still a neutral stimulus. They haven't learned anything about it yet. No conditioning has happened. We're still in that acquisition phase while they're still learning the association. Okay, so let's take a step back. Let's do it again. Let's do it multiple times. Let's do 20 pairings of our conditioned stimulus and unconditioned stimulus. So we ring the bell, give the dog food. Ring the bell, give the dog food. What happens after 20 times? So if we do one of our test trials here, we can expose the dog to just the bell and see what happens. And so if we ring the bell and the dog salivates, even when there's no food around, then we know that our neutral stimulus is now a conditioned stimulus. The dog has learned something about the previously neutral stimulus, and the response is occurring only in response to that conditioned stimulus. So it's a conditioned response. They're salivating because of the bell, not because of the food directly. So we would now call it a conditioned response. And so if we wanted that same information in a slightly different visual orientation, we can look at before conditioning Here they have a slightly different audio cue, a tone instead of a bell. But they're showing that before conditioning, you can play a tone. The dog's not going to do anything. You can give the dog a plate of food, and they're going to salivate in response to the food. So food's an unconditioned stimulus, and the salivation in that situation is an unconditioned response. During conditioning, during that acquisition phase, you would pair your tone and the food. So give the conditioned stimulus and the unconditioned stimulus together, and we're going to be producing that unconditioned response because they're probably still responding to the food. It's a lot more salient while it's present. But after conditioning, if we test it, we would present that tone again, and if it produces a conditioned response, then we know that the tone is now a conditioned stimulus. So that is the end goal, is to have a conditioned stimulus produced, or conditioned stimulus leads to the production of a conditioned response. Okay. And then this last diagram of the exact same process is actually meant to illustrate two different things. We'll start with the first of these, and this is the associations between the different concepts. So before conditioning, we have our neutral stimulus. It's on its own. We have our unconditioned stimulus, and it leads to the unconditioned response. So that's where we start. We will eventually, during that conditioning, during the acquisition phase, we're pairing them. So we have the neutral stimulus and the unconditioned stimulus together, and it leads to our unconditioned response. So that green line indicates that we're learning something about the link between that neutral stimulus and the unconditioned stimulus. And then eventually the neutral stimulus becomes a conditioned stimulus because of what we've learned about its relationship to the unconditioned stimulus. And so then the conditioned stimulus can elicit a conditioned response on its own, and the unconditioned stimulus still elicits an unconditioned response because we didn't change that. But we've established this new process on this side. The second thing that you might have noticed is that the terminology here is using conditional and unconditional instead of conditioned and unconditioned. And that's actually a weird translation quirk. So the original research was done in Russian, I assume, and when it was translated over, there was an issue, and it was translated as conditioned and unconditioned, but that was used for decades. So a more accurate translation would be conditional and unconditional. So talking about the sort of learning process, if you look at sort of the grammar of it, conditional and unconditional makes a little bit more sense. But the sort of established precedent in the field is the grammatically incorrect term that we started with. So this is my way of disclaiming that you might see either term used interchangeably. I typically stick with conditioned and unconditioned because that's how I learned it, and that's how the vast majority of textbooks will teach it. But in case you encounter the opposite. Okay, so let's talk a little bit more about the unconditioned stimulus, so our food or equivalent. And so we can classify an unconditioned stimulus in one of two ways. We can talk about it as appetitive, so it is a stimulus that the animal finds pleasant. So far we've only talked about appetitive stimuli. We've talked about food. Actually, we've just talked about food. But this could also be things like getting to play or attention, things that the animal enjoys. We can also have aversive stimuli, so a stimulus that the animal finds unpleasant. So maybe a loud sound or being exposed to darkness, that could be an aversive stimulus. In early conditioning work, especially like classical conditioning, there was a lot of work looking at things like foot shocks and responses to very loud noises. And it's because sometimes aversive stimuli are a lot quicker to be learned. We learn a lot more strong relationships with them just because they're that much more intense. But as time has moved on and as we've had more strict ethical rules and guidelines, we see a lot less research that uses pain just because it leads to faster learning. So most of the research now doesn't use things that could be painful or uncomfortable unless it's necessary for what they're trying to get at. So a lot of the historical examples will involve things like foot shocks, but nowadays that's a lot less common. Okay, so we can have appetitive and aversive conditioned or classical conditioning, either or. But what makes an unconditioned stimulus a good one? What makes that learning process go better? So in order to be effective, an unconditioned stimulus should evoke some kind of strong bodily response. Sort of bonus points if it occurs naturally. So again, if we use existing reflexive responses, that's going to help us out. That's why, again, those things that cause a very strong response, things like being startled or things that cause pain, were preferable because they made really good unconditioned stimuli. And the idea is the more intense the unconditioned stimulus, the easier it would be to produce a conditioned response. So the more salient or more attention grabbing, the more important that particular stimulus is, the easier it is to learn something about it. There's a caveat here that's sort of more intense is better, but only up to a certain point. In the learning literature, as you get past a certain point, it might sort of plateau, but you might also find that it has an inverse relationship, where if something is too intense, it can block more learning about it. But that is beyond the scope of this course. We just know that more intense is typically better, but too intense can be bad. Okay, so that's the stuff we're looking for in a good unconditioned stimulus. Let's also look at how we can associate our unconditioned stimulus and our conditioned stimulus. So I've kind of hand-waved the fact that we were presenting our conditioned and unconditioned stimuli together. So we said that they were being paired, but we didn't give any specifics of how they were being paired. In our Pavlov example, we talked about ringing the bell and then giving them food, but we didn't give lots of detail there. And there are actually 5 distinct categories that we can use to talk about these types of pairings. So we can talk about the first is a short delayed conditioning or a short delayed pairing. And this is when your unconditioned stimulus would start just after the conditioned stimulus started. So you would have your conditioned stimulus, your tone or bell or whatever, it would begin and it would continue. And while it's continuing, the unconditioned stimulus would start shortly thereafter. And so if I hop here to a visual diagram of this. So on the top, we have our conditioned stimulus, the thing that starts off neutral, and then underneath we would have our unconditioned stimulus, the thing that will automatically produce that response. And so short delay conditioning is going to have, say, a couple of seconds between the onset of one and the other. And so here they were using the example of, so thunder would be a very loud sound, and it would naturally produce a startle response. And then you typically see lightning just before you hear thunder. And so you see lightning just before you hear thunder, and the thunder usually makes you jump. So eventually you would learn to jump when you see the lightning too. So that's what they were getting at in that example. Very, very similar to our short delayed conditioning is long delayed conditioning, which, as you might guess, is just that there's a longer delay between the start of our conditioned stimulus and the unconditioned stimulus. So a little bit more time. And whenever I ask questions about this, I'll either talk about delayed conditioning in general, or I'll specify sort of short versus long. They don't give you a hard cutoff what constitutes short or long. So usually it'll be like under 10 seconds is short, and then 30 seconds plus would be long. Usually that would be something laid out nice and clearly in, say, a operational definition. So if you were setting up an experiment, you would tell people what counts as short and long. So it's more of a technicality than anything useful. But those two are very, very similar. It's just saying that the conditioned stimulus would have been on for a while when the unconditioned stimulus starts. Our next is trace conditioning. And this is the idea that our conditioned stimulus will begin and end before our unconditioned stimulus is presented. So we would hear the bell, and then the bell would go quiet, and then you would give them food. So we specify that there's no overlap between the two events. And again, if you're a visual person, we can have an image for that. So here they have trace conditioning, and this is a long period of time where you would eat something and then get sick much later on. So you can also have shorter trace conditioning. Our only sort of important point here is that there's no overlap. Simultaneous conditioning is our next one, and that one is pretty easy to do without the words on the page, and that's just saying that they occur simultaneously. They're both going to happen at the exact same time. So if they happen together, then it's simultaneous conditioning. And then our last one is backward conditioning. And so this one is basically the exact reverse of all of the other options that we were seeing. So this is the visual for it, but I'm going to hop back to our definition. Nope, that's the wrong way again. I do that every class. So backwards conditioning is where the unconditioned stimulus occurs before the conditioned stimulus. So this would be like giving the dog the plate of food and then ringing the bell. So logically, you might think that this would be a very difficult way to learn anything. If you're getting the food first and then hearing the sound, you're not really going to associate that sound with the food that you got previously. So backward conditioning is one of the least effective ways of setting this up, but it is a way that you can set things up. So we will leave it as one of the options. As an FYI, our short delayed conditioning, so when the two events are very close to one another in time, or when they are temporally close to one another, that tends to help facilitate learning. So our short delayed conditioning is the best kind of learning if you want to learn something quickly. And the last thing that I wanted to talk about was how we can enhance acquisition. How do we make sure that we learn this association better? So the first thing was, already we talked about it. The short delayed pairing is the best way to go. If you can't specifically have short delay pairing, then if you can keep the time interval between the presentation of the conditioned and the unconditioned stimulus short, that's going to help. So that short time interval, the short delay pairing is the optimal, but as long as you keep them temporally close, that's usually okay. The other thing that we can see is multiple pairings of our conditioned stimulus and unconditioned stimulus. Like at the beginning with the dog, doing it just once doesn't necessarily lead to learning, but doing it 20 times or 30 or 100 would lead to a lot stronger learning. So multiple pairings is usually going to be better. And we have a very special case where sometimes very intense and aversive unconditioned stimuli can produce one trial learning. So a fantastic example of this is food aversions. So I use the example of when I was a kid, I drank a large quantity of apple juice that had been left in a car all day in the middle of the summer. I was immediately sick to my stomach, and I haven't enjoyed apple juice since. So that was a single event, a single exposure to that apple juice that made me sick, and I learned right off the bat that apple juice is bad. So we're set up to learn from those very aversive situations, so we can have single trial learning if it's a strong enough event. And so I'm actually going to leave us there for today. We'll continue on with this topic of classical conditioning as we talk about sort of higher order conditioning. We're also going to talk about sort of getting rid of conditioning and other things like that. But that'll be for Friday.